Welcome to Physics Unwrapped YouTube channel. In today's video, I'm going to explain you JJ coupling. That is, in the last previous video, I was explaining about the LS coupling under atomic and molecular physics. These are the concept I'm dealing under atomic and molecular physics, which are very important for KCET examination under physical science subject. Okay, in today's video, I'm going to explain you that is JJ coupling. The JJ coupling, I have took the example of 4P and 4D, that is the non-equivalent case. Yes, let us start analyzing the problem. Okay, if we are clearer with the one problem, it will be very easy for the rest of the problems how to deal with. Now, first, coming to the concept JJ coupling, first we must understand what are the energy levels under JJ coupling. Now, the first energy level under the JJ coupling is spin orbit interaction, that is J vector. Okay, that is the total angular momentum vector. And the second is a residual electrostatic energy. The residual electrostatic energy is nothing but what? L vector, that is a orbital angular momentum. And the third will be spin-spin correlation. Okay, and the third we have spin-spin correlation means S vector. Okay, that is a spin quantum number. What are the energy levels? It is J vector, L vector and S vector. Yes, let us start with the problem. What we have? We have 4P and 4D, right? Now, this problem, that is JJ coupling, cannot be solved without taking consideration into the LS coupling. Similar to the LS coupling, do the steps. For example, what we did in the LS coupling? LS coupling, the first step was what? That is spin-spin correlation. Spin-spin correlation means we need to find the value of S1 and S2, and then we need to find the value of L1 and L2, and finally we will find the value of J. Up to here both are same. For example, here we have a P and here we have a D orbital, right? Now here we have a P means what is the value of L1? If I consider this to be 1, what will be the L1? L1 means for L which is equal to 0, we have S. For L which is equal to 1, we have P, and L which is equal to 2, we have D. So on like that. Right. For this example, I am taking for L which is equal to 1, we have a P. Right. So L which is equal to, what is the value of L1? That is 1. And what is the value of L2? That is, what is the value of D? D value is 2. Okay. And next we need to find the S1 and S2. Obviously, we know the S1 and S2 for the electron to be half and half. Right. For any electron, what should be the value of the J vector? J vector is nothing but L minus S vector. That is a magnitude of L minus S vector to magnitude of L vector plus S vector, right? Now, if I do this, the J vector is nothing but magnitude of L vector minus S vector to magnitude of L vector plus S vector. Now, come to the first, that is L vector minus S vector means 1 minus half to 1 plus half. So 1 minus half to 1 plus half is how much? 1 minus half to 1 plus half. So 1 minus half to 1 plus half can be written as 1 minus half is 1 by 2 and 1 plus half is 3 by 2. And this I'm calling it as what? This I'm calling it as J1 because we did this for a L1 and S1. Now we are doing for L2 and S2. For L2 and S2, what is the value of J2 vector? J2 vector which is equal to 2 minus half to 2 plus half. I hope you people are getting. So 2 minus half is what? 4 minus 1, that is 3. 3 by 2. And 2 plus half, that is 2 2s are 4. 4 plus 1 is 5. It will be 5 by 2, right? 3 by 2 and 5 by 2. This is the value of J2. Now finally we got the value of J1 and J2. Let us move to the next slide and we shall write here again the value of J1. The value of J1 here is 1 by 2 and 3 by 2, and the value of J2 is 3 by 2 and 5 by 2. Okay, now we must find the values of j values for any electron, right? Now we know that the j value, that is a j vector values, will run from j1 minus j2, means that is combination we will be having. We will be getting the four combinations, that is I'm going to write, you will be very clearer, like half and 3 by 2. If I combine these two, it will be half and 3 by 2. And one more j value will be half and 5 by 2, right? And one more j value will be 3 by 2, 3 by 2. And one more j value will be 3 by 2 and 5 by 2. So we are having the four set of values, that is half and 3 by 2, 1 by 2 and 1 by, this is 1 by 2 and 3 by 2, 1 by 2 and 5 by 2, 3 by 2, 3 by 2 and 3 by 2, 5 by 2. Yes, I hope it is clear to you people. Now if I do that is a j2 minus j1 vector like this, the magnitude 1 half minus 3 by 2, 2 half plus 3 by 2. What are the values we are getting? So inside the magnitude will get the positive values only. It will be minus 2 divided by 2, it was 1, 2. It will be 4 divided by 2, that is 2 ones are 2 twos are. So we are getting the values 1 and 2. Okay, these are the values of j. J value, how much we are getting? The j value which is equal to 1 and 2. Now what we did, I'm going to, from the first, we just segregated into four parts. Okay, we have just segregated into the four parts, and that we are doing, that is actual method, that is j vector which is equal to j2 vector minus j1 vector, or j1 vector minus j2 vector inside the magnitude to j1 vector plus j2 vector. And now we will do for the next term, as you can observe, that is 1 by 2 minus 5 by 2 will be what? 4 by 2, right? So 4 by 2 will be 2, and here if we plus 5 plus 1 is 6, 6 by 2 is what? 3. So we are getting the next j value to be 2 and 3. And next we have a 3 by 2 and 3 by 2. 3 by 2 and 3 by 2 means 3 by 2 minus 3 by 2 to 3 by 2 plus 3 by 2. Okay. Now if I solve this, we'll get the value 0. And if I solve this value, we will get the value 2. 6 by 2 is 3. Means what are the values? 2, I'm telling it is 0, 1, 2 and 3. So we are having the four values. In the next term, that is the fourth term, we have 3 by 2 minus 5 by 2, that is 2 by 2 if I subtract. So I'll get the value to be 1. And we have 3 plus 5. 3 plus 5 is 8. 8 by 2 is what? 4, right? So it will be 1, 2, 3, 4. Okay, these are the values. We are getting the j values for the respective combinations. Now if they ask in the question, they can ask from what are the sets, and they can ask what are the j values, what are the combinations from jj coupling, they can ask. For this the answer will be this, and what are the values of j also they can ask. Okay, now the JJ coupling can't be drawn alone. With the help of the LS coupling only we can draw. Now in the previous classes, that is previous two classes, I have taught you about the LS. In the first class, it is LS coupling for non-equivalent case. There I have drawn the diagram for LS coupling under the case, that is I think 4p and 3d. Here the case is just 4p and 4d. Okay. Now let us draw for LS coupling, and then we will analyze what will be the solution, what will be the energy levels for the JJ coupling. Okay, now for the LS coupling, what we have, the lower value of S will accommodate the higher energy level, and the lower value of L will accommodate the higher energy levels. And if we have a half filled electronic configuration, means then the lower the value of J will get the lower energy level. When we have a more than half filled means lower the value of J, higher energy levels. So if I apply these set of rules and split the energy levels, this is how we are going to get. I'm going to draw directly. You can refer the previous video. Okay. Now the first set here we'll get like uh, it is split into 3. So it is split into 3 that we are having 1p1, and here we have the energy level to be 1d1, and here we have the energy level to be 1f3. Okay, so here it is 2 now, and one more energy level. The next step we were having, that is 3p2, and the level is 3p1, and one more level is 3p0, and the next we have 3d2, and we have 3d 3d3, and we have 3d2, and with reference of the above only we can solve, and we have 3d1, and next we have with the increment of 1 to the f, so it is 3f4, and we have 3f3, and we have here 3f2. This is how we got the energy levels. This will be the 3f2 will be the lower energy level, and 1f1 will be the higher energy level. And how many levels we have, you can observe here we have the 12 levels, right? Now that we have studied in the previous class. Now what is our task is, I'm going to rewrite this again, that is 1 by 2 3 by 2, and 1 by 2 5 by 2, 3 by 2 3 by 2, and 3 by 2 5 by 2. These are the combinations we have got, right? Let me write this side. Down I will write. So it will be 1 by 2 3 by 2, and we have 1 by 2 5 by 2, and we have 3 by 2 3 by 2, and we have 3 by 2 and 5 by 2. Now concentrate here. With this is the LS coupling. With the reference of LS coupling, I'm going to draw the JJ coupling. Now how the JJ coupling looks like, we will see now. Here we have a 1p1, and we have a 1d2. So in the previous slide we got the values, the J values to be 1 and 2. For what? The way J values is 1 and 2 for 1 by 2 and the 3 by 2, right? Now I can combine these two and write. I can combine these two and write like this. So this energy, that is 4p and 4d, is completely given by, this is 1p1, and here we have a 1d2. The J value is here 1, and here the J value is here 2. Okay, I hope this is clear to you people. And we are having the combination, that is 1 by 2 and the 3 by 2. And next combination is 3 2 1 0. I'll go to the previous slide and see 3 2 1 0 or 0 1 2 3. That is 3 by 2 and 3 by 2, right? So 3 by 2 and 3 by 2, I can write here the same. From here to here I'll combine and I'll split. Okay, see here how I'll do. So here I'll write it as 1f3, and here I'll write it as 3p2, and here it will be 3p1, and here it will be 3p0. Okay, so what are the values of J? The J value is J which is equal to 3, and here J which is equal to 2, and J which is equal to 1, and J which is equal to 0. Now the combination is what? The combination is 3 by 2 and 3 by 2. Okay. Now the next what we have, up to here we are done. 3, 2, 1, and we have 4 as well. Concentrate here in the previous slide. 1, 2, 3, 4, and the remaining is 2 and 3. Okay. Now we'll come here and we will see. Here we have a 3, 2, 1, 4. I can write it as this set as 1, that is okay. So I'll write it as 3D3, and here 3D2, and here 3D1, and here it will be 3 um F4. Okay, so we have 1 2 3 4. So the J value here is 3, and here J value is 2, and here J value is 1, and then here J value is 4. Okay, and we are getting the combination to be, which combination we got, that is 3 by 2 and 5 by 2, right? So 3 by 2 and 5 by 2. Okay, now and we have the one more set called, we are left with 1 by 2 and 5 by 2. What are the values of 1 by 2 and 5 by 2 from the previous slide? 1 by 2 and 5 by 2 is 2 3. So we want to draw the final energy level, that is 2 3. Now 2 3 can be written as, that is 3F3, and here 3F2. Okay, 3F3 and 3F2. Here the J value is what? J value is here 3, and J value is here 2. Okay, and we have the combination called 1 by 2 and 5 by 2. Okay, this is the electronic configuration of JJ coupling with help of the LS coupling. Directly we can't write the JJ coupling. With the help of the LS coupling only we can draw. I hope everyone is clear with the splitting of the energy levels under JJ coupling. Here also we have how many levels? We have 12 levels only, but the energy level splitting is quite different, and they'll ask the combination, like which is the combination which is having the higher energy and which is the combination which is having the lower energy. At that time you can easily answer using this JJ coupling. Okay, now under this we have one more concept that you need to be familiar for the transition. Like under JJ coupling, I have discussed the selection rule under LS coupling also. Under JJ coupling, the selection rule is only, that is delta J value to be equal to 0 or plus or minus 1. Okay, only these values are allowed. In the previous case, other than these values, we were having delta S which is equal to 0 and delta L which is equal to 0 plus or minus 1. So in this case, in JJ coupling, it is not allowed. Okay, that we must be very clearer. And here we are not considering the value of ml and ms values. We will not take into values not allowed, or we will not consider. Okay, only the values are allowed as mj and j values are allowed. Okay, so I hope everyone is clear with this video about the JJ coupling under non-equivalent case. In the coming class, I will be dealing with the equivalent case. Once I am done with the equivalent case, I will be solving the previous year question papers from KSET as well as NET. So you can attempt easily if they arise any question from this topic. This topic is quite important. Thank you for watching. For more videos, you can visit my YouTube channel. Thank you again.